Now look student, that is 14a. If root over a minus b plus root over b minus c plus root over c minus c equal to 0, then prove that a equal to b equal to c. Actually student, this question is not belong to class 8 advanced maths. Actually this question belongs to class 10 advanced maths, and I have to take some concept from class 10 obviously, and I will explain now one by one all the terms of this 14a. Let's have a look how to solve this one, this 14a. Now look student, 14a, this is the given part, so we'll write here now given we'll write here now, this is a given part. Now look, after that, the difference between a minus b, b minus c and c minus b, so must be positive. I repeat again, a minus b also, you have to be positive, and b minus c positive, c minus c also be positive. If it is negative, then we can say that it is imaginary. Now what is the meaning of imaginary square root? Or we can say that square root will be imaginary. Why? Look here now, what is the meaning of imaginary? Look student, inside the root over a minus b, if a minus b is positive value, suppose 2 minus 1 positive value, or if it is a minus b negative value, means 1 minus 2, then negative value. If it is negative, then we can say that it is a imaginary. Now what is the meaning of imaginary? Look here now, inside the root over, if value is minus 1 or minus 2 or minus a or minus b, whatever may be, inside the root over, so we can say that this whole is called imaginary. We call it imaginary. This concept is totally, belongs to the complex number, and this concept is belongs to class 10 advanced maths. Anyway, since the question is given class 8 also, so we have to solve. So here in this question, the main concept is, so a minus b should be positive. If it is positive, then okay. If it is negative, then it is imaginary, and if it is imaginary, we cannot take the value. So here this a minus b, b minus c and c minus a should be positive. Now look here, we'll write here that the expression a minus b comma b minus c comma c minus a must be positive. If it is positive, which means value should be say 1 2 3 or 4 5 6, whatever may be. Otherwise we can say that, their square root will be imaginary. Imaginary meanings they are having minus sign inside the root over. Okay, now after that student, if their expression is positive, which means their square root is also be positive, so we can write that therefore the square root of the expansion or the expressions, square root of the expression must also be positive. Now look, what is the expression, which means this one. If their difference is positive, then their root over value, which means square root value, is also positive, not imaginary. Imaginary means there is no minus sign inside the root over. Now look, after that student, after that, therefore their sum, which means this all, root over a minus b plus root over b minus c plus root over c minus a equal to 0. Their all sum is 0, which means then it is said that square root value is also positive, which means this also. Therefore we can say that root over a minus b equal to 0, and root over b minus c equal to 0, root over c minus a equal to 0. Why? I have to write one sentence here. The sentence is actually, if the sum of positive expression is 0, then each of the term also be equal to 0. Now look, after that student, now here, therefore root over a minus b equal to 0. Now if I go for the squaring both sides, then what will happen here? A minus b whole square, then 0 square. Square root cancel, there is a minus b equal to 0. 0 square is 0 only. So a equal to b, our first equation. Now second one, root over b minus c equal to 0. Then squaring both sides, which means root over b minus c whole thing square equal to 0 square. Now b minus c equal to 0, then b equal to c, equation number 2. Now next one, root over c minus a, equal to 0. Now if I go for the squaring both sides, c minus a whole square equal to 0, then square root cancel, c minus a equal to 0, then c equal to a. This is our equation number 3. Now look student, after that, from 1, 2 and 3, a equal to b equal to c and c equal to a. So we can write here from 1, 2, 3, we have a equal to b, b equal to c, c equal to a, which means a equal to b equal to c, hence proved. This is the answer of 14a.